Good afternoon.
Good afternoon.
All right, there's Chloe back and friends. Let's see, St. John's. Do we have the guys there in St. John's?
One more's picking up his textbook.
Okay. All right. Yeah, could you aim the camera down just a little bit in St. John's? Okay, so let's see. Uh, so is Den in there in Mogion?
No, he's not.
Okay. All right. So are the other two coming in St. John's?
I don't know where they are.
Okay. All right. Well, before we get started, so did anybody do anything amazing over the weekend?
Hey, Denon's here
I'm
now.
here, Mr. Strong.
Awesome. Awesome. So other than Denon showing up, anything else awesome happened over the weekend?
I got stuck in a car crash traffic for 4 hours on
What?
Saturday or on Sunday.
But you weren't actually in the crash.
No, I was not in the crash. Thank goodness. I almost was because some stupid drivers, but that's beside the point.
Yeah, well, that's good though. I mean, at least you weren't physically harmed. I know last time I don't know if I told you this, but when last time I drove through Payson, it was a victim of hit and run. Well, I was in the Walmart parking lot, so that was not cool. Let's see. What else? Anybody else do anything amazing?
We got to play Joe City this week.
Oh man, that'll be fun. That'll be fun. There, I will tell you, this is my scouting report on Joseph City, free of charge, that I'll give you. Is I have seen games when they play so good that I think you'll have a hard time beating them, and I've seen them play games where it just seems like anybody could have beat them. So they have a real problem with consistency. But anyway, so I don't know what that's worth. But it wouldn't be surprising to me if you guys beat them. But it wouldn't be surprising to me if they beat you either. So, because haven't you guys had an up and down season too?
Yeah, a little bit. We've had like 2 rough games.
Yeah. So it's kind of, I think, probably the same as theirs, where, I mean, anyway, they, I would expect, usually when teams are like that, then you get a high scoring game. So I'd bet the over this time, except I don't do that, but anyway. All right, well, that's exciting. Unfortunately, I might not make it because might have to go to St. George this weekend to see my mother, so might have to miss the game. Dang it. So anyway, well, let's go ahead and get started. We're in 3.4.
Professor Strong,
Yes.
I'm just letting you know that I'm here.
Oh, thank you.
Yeah.
Thank you. Appreciate that. So what about Nathan? Anybody know about him yet?
He is not here yet, and I don't know where he is.
Okay. All right. Well, we'll get started here. So I want to just well, actually, the last blank right before part 3 says, besides telling us how fast an object is moving, its velocity tells us what? What does the velocity tell us besides how fast?
Direction.
Direction. Okay? And so that's kind of where it's kind of leading into this this screen right here. This isn't really on your notes or anything. So it's just kind of comparing average velocity and instantaneous velocity. Now, when we say just velocity, it's assumed to be instantaneous. So to calculate average velocity, that's what we did at the beginning of chapter 2, where we did the difference, change in position over the change in time, and that was no calculus at all. But now as we get into applications, we're going to have more and more problems with velocity. And so that's where you take the derivative of the position. And so that's S prime, the derivative of S, so we'll say S prime. And so since we're taking the derivative, that does involve calculus, okay? All right, and then, okay, so now we'll go to part 3. So the metric free fall equation is S equals negative 4.9 t squared. Now, I had given you the Newton's free fall equation, which was negative 16 t squared, but that's in feet per second, feet in seconds. And so then we have the metric version of it. So the rate at which a body's velocity changes, then that's the acceleration. So we talked about that being the derivative of the velocity. And so we'll also have problems that involve acceleration. Okay, now, it says the figure shows a ball bearing falling from rest at t equals 0 seconds. Use the metric free fall equation, S equals negative 4.9 t squared to find. Okay, so let me just kind of set this up for you, okay? So, all right, so are any of you 18 now? Okay, so imagine that you just graduated from high school and you go to college and you really don't know what you want to major in, but you know you're good at math and you kind of think, well, maybe physics, okay? So you're in this physics program, and so they give you keys to this like $1 million lab, okay? Anyway, that was me as an 18-year-old. I couldn't believe I had this lab, and it was pretty cool. Well, one of the things that they had is it was a device for you to actually calculate the acceleration due to gravity experimentally. So even though we know the acceleration due to gravity, this was kind of a cool experiment where you would actually calculate it. And what they did is they had like a pole. It was a metal pole, and it went up pretty high. And then on the outside of this pole, they had this like little metal wire that would run down the side of the pole. And then the pole was connected to this control panel that did all kinds of cool stuff. Well, so in an experiment that we did that's kind of described here is that you would have like a little ball bearing, like a steely, and you'd take it to the top, and it was the wire threaded through this little metal ball, and it had this little housing that where you would get it, and it would hold it in place, okay? And then what you would do is this control panel, you would set it so that every 1/10 of a second, half a second, whatever you wanted, it would actually send out electric bursts through the ball on this wire to the metal pole. And so what you would do is actually feed through this like piece of like tape, look like paper, like register tape. So you would feed it through so that it would be between this little wire and the pole. All right, so basically what it would do is when you would release the ball and you would have it set to, let's say, do an electric charge every 10th of a second, then what it would do is as it would go down, it would burn the little electric spark would burn a hole through the paper. All right, so it's pretty cool. And then then you could, when you were done with the trial, you roll the paper out and then you would measure. So you'd measure how far it fell every 10th of a second or every second or whatever. Okay, and so you could use that to actually determine gravity. So now this has, the units are in meters, which is kind of ridiculous because that would mean it'd be like the tallest building in Navajo County. Okay, so I mean this is 45 meters. That's half a football field. All right, so but anyway, so then you're releasing this ball, and so every second here, then it's making a mark, or you're reading how far it's fallen. Okay, so it says how many meters does the ball fall the first 2 seconds? Well, you can sort of eyeball it here and say, well, after 1 second it's fallen 5 meters. After 2 seconds it's about 20 meters. Okay, or you can actually use, here it says use the free fall equations to find. So if we want to know the change in position, like how far it's fallen, then that would be its position at 2 minus the position at 0. So that would be negative 4.9 times 2 squared minus 0, or negative 19.6 meters. So my estimate of 20 meters is actually pretty good. Okay. All right, then it says, what is its velocity, speed, and acceleration then? So the then refers back to the previous problem at 2 seconds. So to get its velocity, we take the position equation and take the derivative and then plug in 2. So if we plug in 2, the v of 2 would be negative 19.6. So then that means that the speed, you take the absolute value, because remember the speed is always positive, it's the absolute value of the velocity. So the speed is positive 19.6. And then the acceleration, you take the derivative of the velocity, which is negative 9.8. Now there's no t to plug in, so that means that's the acceleration due to gravity at any time. Okay, negative 9.8 meters per second squared. All right, so any questions on that? All right, so let's have you do practice 3, please. Is there a question?
I just want to let you know I'm here.
Oh, thank you, thank you. All right, so Chloe, how many meters does the ball fall in the first 3 seconds?
Negative 24. 1 second. Wait, is it 44.1 meters?
Yeah. Yep, the ball falls 44.1. How okay, what's the confusion here?
Nothing. We got confused with we were doing part B of the last one.
Oh, okay.
Yeah. Yeah, that's what I thought.
Okay. So 44.1 meters. So its change in position is negative, so that means it's falling. But since it's set, the question is how many meters does the ball fall? If the negative is sort of assumed in the question that it's going down. Okay. All right. Good. All right. So what are its velocity, speed, and acceleration then? So let's start with velocity. All right, Nathan, I don't know if you heard enough of the example to get it, or
What is he asking for?
The velocity.
Velocity?
at
Oh,
3
velocity.
seconds.
Velocity is negative 14.7.
No, so it's negative 9.8 t. See, let's go back. So here's the position equation. So the velocity equation is the derivative of that. So that would be negative 9.8 t. So then at 3 seconds, you plug in 3. So negative 9.8 times 3. So that would be negative 29.4 meters per second. Is that okay? Does that make sense? Okay.
Yep.
All right. All right, so Chloe, welcome back. I guess we're gonna pick on you for a little bit. So Chloe, what's the speed at 3 seconds?
29.4.
Right, it's the absolute value of the velocity. All right, and then finally, the acceleration at 3 seconds. Chloe again.
Negative 9.8.
Negative 9.8. Very good. So because there's no t to plug in, that means it's constant. Okay. And really for free fall, if they're unless it's thrown to the earth or something like that, or thrown up in the air, if it's just the only acceleration that's usually going to be acting on it is going to be gravity. Okay. All right. Any questions on any of those? All right, so part 4, the maximum height. To find the maximum height, you find when the velocity is 0. Because as an object is going up, as we talked about on Thursday, when it reaches its maximum height, the velocity goes from positive to 0 to negative. So it comes back down when its velocity is 0. All right, so this is a dynamite blast, blows a heavy rock straight up with a launch velocity of 160 feet per second. So here's the dynamite blast, and it goes up. It reaches a height of S equals 160 t minus 16 t squared feet after t seconds. Okay, so that's the path the rock takes. Okay. All right. So it says, so how high does the rock go? So again, you take the derivative of the position, and that's the velocity, and you set that equal to 0, and then you solve for t, and you get t is 5. Now, but the max height isn't 5. The 5 is when it reaches its maximum height. So when you take the derivative, set it equal to 0, that tells you when it's at its maximum height. To actually calculate the maximum height, you have to plug that 5 into the position equation. So you take the S of 5, 160 times 5 minus 16 times 5 squared, and you work that out, and it ends up being 400 feet. So that's the maximum height of the rock. So it blasts and it goes 400 feet in the air. Okay? What are the velocity and speed of the rock when it is 256 feet above the ground on the way up and on the way down? So if its maximum height is 400, then it's going to hit 256 feet on the way up, hit 400, and then it's going to be 256 feet on the way down. So we're just picking that, okay, at those two values, what are its velocity? Okay? So we take the position, so we have to figure out when that happens first. So we take the position function and set it equal to 256. And so then we solve that for t. So to solve that for t, one of the things that will help you on these problems is if you divide out a GCF. So like in this one, I divided out a 16. Then you're either going to solve this by factoring or using the quadratic formula or graphing or something. But it will make your life a lot easier if you divide through those common factors. Is there a question? Somebody's got their mic open. I just assumed there was a question. Okay. Well, anyway, so in this one, it factors. So then when you set each factor equal to 0 and solve it, you get t equals 8 and t equals 2. So what that means is that times 0 is when we blast the rock. And then after 2 seconds, it hits that height. It goes up some more. And then on 8 seconds, after 8 seconds, it's that same height, 256 again. Now, so we've got the when, and now we need to find the velocity and speed at those two times. So we take the velocity at 2 and the velocity at 8. Now when we plug in the v of 2, we get 96 feet per second. So that means since it's positive, it's also the speed. But the v of 8 on its way down, its velocity is negative, so you take the absolute value for the speed. Okay? So that's the speed at 8 seconds. Let's see. Velocity and speed on the way up and on the way down. Okay, and then finally it says, what is the acceleration of the rock at any time t during its flight after the blast? So there you take the second derivative, and it's negative 32. When does the rock hit the ground? Well, it hits the ground when the position is 0. So you take the position function and set it equal to 0. And see, there's no calculus on that. You're just taking it and solving, set it equal to 0 and solve. So it's at time 0, it's at the ground. And after 10 seconds, it goes up and it comes back down and hits the ground again. Okay? All right, so go ahead and try practice 4. And if there's a part that you want to see again, you want me to go back through the example, there's a certain part, let me know. right, so Rhett, how high does the rocket go?
625 feet.
Yep, that's it. All right, great job. Any questions on that? Okay. All right, what are the velocity and speed of the rocket when it is 100 feet above the ground on the way up and on the way down? All right, Joran.
I'm still stuck on factoring it right now, so it might be a while.
Okay, well, when I go to solving, let's just see a couple of things here. First of all, did you divide everything by 4 to make the
I did it by 2, so but not by
Okay.
4. I didn't see, so you can do it again by 2. Okay.
Yeah, because they all still would be even. So if they're all the coefficients are even, you can divide by 2 again. So here's the thing: is as far as factoring goes, is that really and truly, if I were doing this problem and I can't factor it in my head in like 2 seconds, then I just bail and use the quadratic formula. Because there's no sense in spending a lot of time, because it might be that it doesn't factor. And so you don't want to waste your time if it might not factor. So I would just use the quadratic formula on this. So do you need some help with that, or do you think you got that?
I have it. I just was
Okay.
having complications thinking.
Okay, all right, well, that's fine. Just take your time. The other thing that what's something else you could do? Let's say if you don't really want to use the quadratic formula, what's another way that you could get the answers here? Come on, you guys should know my tricks.
Do you do the derivative?
No. No, what you do on this is if you actually graph it, okay, this is a pre-calculus trick, that you could graph it and then find the x-intercepts. So you could do it in your calculator with second calc 0. But you have to be able to see the graph, so see where it intersects. So, but usually you could do that. So, but if you're having trouble with the quadratic formula here, you might try putting it in the calculator.
I'm sorry, I'm having a really hard time focusing today.
Okay.
I can't get this.
Okay. All right. So here I let A be 4, B is negative 50, C is 25. So you use the quadratic formula. So you get the opposite of B plus or minus the square root of B squared. Now, the most common mistake that students make in a problem like this is they will forget to put parentheses around the negative 50. So when you square a negative, it has to be in parentheses. Otherwise, your calculator is going to do 2,500, then take the negative of it, and then you'll get an I in your answer, and you'll be screwed up because you know that the answer is not complex because it has to go up and has to come down, but you won't get it at that point. And that's why. Because when you square a negative, you have to have it in parentheses. So minus 4 times A times C all over 2A. So that would be 50 plus or minus 2,500 minus 400 all over 8. So that's 2,100 over 8. And so then there I would, when you put this in your calculator, if you're going to do it in the calculator, well, you might as well do it in the calculator at this point. Make sure you put that numerator in parentheses. Because whenever you have more than one term. So parentheses 50 plus the square root of 2,100, or 10 radical 21 over 8. And then 50 minus. And so you get 2 times 11.978 and 0.522. So now you've got to put those in to the derivative. So when does it reach its highest point? No, what are the velocity and speed at those points? So we plug those into the velocity function. And so we get negative 183.292 when you plug in the bigger one, positive 183.292. So when you plug in 0.522, you get 183.292. So one's positive on the way up, about a half a second into it, and then almost 12 seconds, it's going to be coming down. And then the one that's negative, its speed, well, the speed for both of them is positive 183. And that might seem, I know when I studied physics, I guess I didn't realize that, like, you know, barring like wind resistance or whatever, if you threw a ball up in the air and it comes down and hits somebody, it's going to hit them at the same velocity that you threw it. Okay? Or even a better idea is that, or maybe there's a worse idea, is, in the movies when they take guns and they shoot them up in the air? Well, that bullet, when it comes back down, it's actually going to have the same velocity as the muzzle velocity of the gun. So however it shoots out, I mean, yeah, it's going to come up in the air, but when it comes down, it's going to have that same initial muzzle velocity minus wind resistance. Okay? Which is crazy. But anyway. All right, so Jordan, is that okay, or do you need some help on solving that, or what?
I don't need help. I'm just having trouble concentrating today, so it's
Okay.
my brain isn't working.
Okay, no, listen. That happens. That happens to everybody. You just have days. Just get a good night's sleep. Okay. I know. I learned that it's really hard to do calculus when you're sleepy or when you're like that. Because calculus does require a certain amount of attention, and like if there's a lot of distractions in your room or whatever, it's hard to do. So anyway, what I'm telling you though is, like, if it's really hard sometimes if you're in that kind of frame of mind and you're taking a test. That's tough. That's really tough. I would recommend Mountain Dew at that point. Something that, but on this one, the other thing where I was talking about using the calculator, that's something that you can do with less brain power, is to actually put it in and find the zeros. Do you know how to do that, or do you need me to go through that?
I can do that. My calculator is being weird though, and it'll only show me 1/2, but then I go out and it doesn't show me it at all, so I can't narrow in. I'm not sure if I'm not putting in numbers right, but my calculator is being weird.
It might be the Zoom. So you might try, on this one, Zoom Standard isn't going to work because you actually need to see, I would set your X min to 0 and your X max to 20 for a problem like this, so that you see the first 20 seconds. And then you really don't have to see how high it goes on this problem. You're trying to find out, what's going on at 0 seconds and at you're trying to find the zeros here. So the way that you would find those is see where the graph, when you set it equal to 0, you're trying to find where this graph crosses the x-axis. So you don't really need to see the top of it. You just need to see the zeros. So are you seeing that? Are you seeing where it crosses the x-axis?
I can only see one side. I can't get far enough out to see both sides.
So
Which
set your window to go from 0, x min at 0 and x max at, say, 15 or 20. All right, then when you press graph,
all I can see is one leg of the graph. It's not showing me the other half of the graph, and I don't know if that's just because I'm not zoomed out far enough, or what that is. But I can only see
you still
the first
should
side.
see. Okay, so if this is your window here, I mean, you might not have the perfect zoom here, but what's your Y min and Y max?
My Y minimum is -1, and my Y max is 100.
Okay, that should still work, because you still should see this, and it might go up here, and you might miss part of the graph, but you're trying to find these two zeros. You should see those where it crosses the x-axis. And so if you're going from like 0 to 20 here and -1 to 100 on the y's, your calculator must be messed up.
It has to be because I'm not seeing anything now.
Did you plug? Wait, can you turn it on?
Yeah.
Did you plug in the original equation or the equation with plus 100? Because that might be it.
I plugged the original equation in.
Okay, that's it then. Thank you. Yeah, this is the equation that you simplify and have it set equal to 100. That's what you have to plug in because that's what you're trying to solve at this point.
I don't know what is wrong with my calculator. No matter
Okay.
what I do, it's not showing.
Well, if you're already kind of having a frustrating day, so I don't want to add to it. But let me just suggest this. I mean, I don't know if you have a whole lot of stuff saved on your calculator, but when you are having major problems with the calculator and it's not doing what you think it should be doing, then what I would recommend is you just go to second memory, and then you could, and unless you have a lot of apps and stuff going, if you just reset it, because there are apps that actually mess with the graphing. And if you're not careful, like the inequality one, I don't know if there's some of these apps that some of you play with or whatever, but there's actually some apps that mess up your calculator. Okay, it's, so I would just do periodically, if you have trouble, just do a reset. And then you basically you can reset all the RAM, all the defaults, everything back to normal, and it will quit all your apps. And if you've downloaded anything or people put stuff in there, where I used to have calculators for a classroom, right? And there would always be these evil little demon children that would go in, they would mess up the calculators for the next person, okay? I didn't mean to call you out like that, Hannah. But yeah, we don't, anyway. Sometimes you gotta take drastic steps. And sometimes it's not your fault. It's just like getting something wrong with your computer. All right, well, anyway. Okay, let's go on to the next part. What is the acceleration of the rocket at any time t during its flight? All right, Skylar?
Was it negative 32 meters per second squared?
Negative 32 feet. Well, I think this one's in feet, but yeah, per second squared. All right. All right. Well, let's, I think that's a good place to stop. Oh no, we have one more. When does the rocket hit the ground again? So let's answer that one. Hannah Z.
After 12.5 seconds.
After 12.5 seconds. Very good. So you could set the position equation equal to 0 and then solve it. Can anybody think of an easier way to do it?
Graph it.
it.
Okay, how about easier than that? You kind of have to know a little bit of physics though. So maybe you might not know this little secret. See, okay, Rhett, in your problem, you had part A, right? See,
Yeah.
how high it went? How long? What was the time it took to reach its maximum height?
$6.25.
And so it takes 6.25 seconds up, 6.25 seconds down, 12.5. So anyway. All right, well, we'll pick it up from there tomorrow. And then, the plan for Wednesday is we're going to take the chapter 2 test. Okay? So not quizzes this week, but the chapter 2 test. So be studying for that. And, but we'll continue on. Any questions that you have?
So when will we do the quizzes then?
After the next week, after the test.
Okay.
So we've done all the quizzes for chapter 2. So, right?
Yeah.
Yeah, so we'll take the test and then next time. Okay? All right, we'll see you guys.